The video will cover section 4.4, and it is part 2 of the section. In the last class, we left off defining a reference angle. And so a reference angle is like the one that you can see here. And it is formed by the terminal side of the original angle, which in this case will be theta. And here's the terminal side of that angle. And it's also formed with the x-axis. So that's what we call the reference angle. And also it is a acute. You already have this on your notes. It's an acute positive angle. No. The original angle, it will be the non-acute. Like that.
Are you writing the definition for reference angle?
No, I'm just kind of like a very last, like a summary.
Oh.
Because I know that your definition says, let theta be a non-acute. So when we say theta, we're talking, that's what I mean by original angle. That's theta. And then on your notes, after that, it should say, its reference angle is the positive acute angle, which we call theta prime, and it is formed by the terminal side of theta and the x-axis. So right here, this will be the reference angle. The one here, this is the terminal side of theta. Here's the x-axis, and here's the reference angle. For this one here, we have the terminal side of theta, x-axis, reference angle. All right? So now what we're going to do to solve the problems is we're going to be finding it numerically. And I can tell you, just to be honest, I'm not very good at doing this unless I draw the angle. I have that thing. So some of us are more visual. So whatever works for you guys. If you don't need to draw the angle, that's fine. But if you do, I find that actually very helpful. So I'm having issues with my mouse. The battery is about to die. All right. So again, reference angle is going to be less formed by the x-axis, terminal side of the original, and it is an acute angle. That means it's less than 90, correct? All right, so let's go ahead and answer the problems. And if you see here, they're actually recommending drawing the original angle so we can get an idea where the reference one will be at. So let's answer the problems here. And we have the angle 345. That's our original angle, theta. So I'm going to go ahead and make a little picture of that. And so we know that a complete rotation is, we know a complete rotation in degrees is what? 360. So we know we're going to be a little bit before we get to 360, right? Yes or no?
Yes.
Yes. So this is the angle in purple. That will be my original angle, okay? The 345. Now my reference angle is going to be formed by the terminal side of that original and the x-axis. So that will be theta prime. So in this case, we could find it numerically by doing this. Theta prime will be equal to 360 minus 345. And so that will tell us that theta prime is equal to 15. Okay, let's move on to the next one. So we have here 5 pi over 6. And so what is a complete turn again? How many degrees? I mean in radians.
2 pi.
2 pi, right? So if we go the whole turn, we start at 0, and then here this will be 2 pi. Right here on the negative x-axis, that will be pi, right? Yes? Now, if we were to divide pi in, this is a 6, just so you know. in 6 equal parts, then pi will be like 6 pi over 6, correct? Yes? 6 over 6 with a pi. So since we want to plot this angle 5 pi over 6, it's going to start here in standard position. And it's positive, so we go in the counterclockwise. And are we going to go before or past pi? Before, right? And it's actually, so right here, that would be the reference angle. So numerically, the reference angle, we could find it by doing the operation pi minus 5 pi over 6, which is equivalent to 6 pi over 6 minus 5 pi over 6, and that is equal to pi over 6. Remember, reference angles are always acute and positive. All right, so next angle that we have here is negative, the original one, which is 135. Negative 135 right here. So this angle, negative direction, so we start here, standard position on the positive x. Vertex is at the origin, but now we go in the clockwise direction. Now it is negative 135, so will that be, we'll start here at 0 degrees, this will be negative 180 if we go in the negative direction, right? Clockwise. So negative 135, will that be before or after the negative 180? Before. So it will be somewhere here. So that will be angle theta. Now the reference angle is going to be formed again with the terminal side of theta and the x-axis. However, the reference angle is going to be positive. All right? So numerically, what we're going to do is the reference angle will come from negative 135 degrees plus 180. And so theta prime will be positive 45. Or you could say 180 minus 135. All right, now the last one here is in radians. How do I know it's in radians, guys? It doesn't have pi. It doesn't have the symbol for degree. Yeah, that's also true. Well, degrees could also be in decimals. But the fact that it doesn't have the symbol right here, that tells me if it's not degrees, then we're talking about radians. So this is 2.5 radians. Think about it. If this is pi, what is an approximation of pi? So if we want to plot that angle in radians, we start here, and then we're going to go a little bit before we get there, right? To the 3.14. So that's theta. So then to find theta prime, which is going to be here, will come from pi minus 2.15. 2.5, yes, I'm sorry. Do you guys have a calculator handy? I don't have the answers. We won't really need one, Chris, but you already got up.
0.641.
1.
0.641.
0.64.
Aye, be patient. Okay, yes. So that will be the reference angle right there. Still in radians, okay? All right. Now let's see what we have here. And so, there we go. So we're gonna find the reference angle for this one here, and if you notice, they're actually over 360 or over 2 pi, right? So for the first one here, we start at, we need 580 degrees. So if we complete one turn, how many degrees is that? 360, right? And then how many more degrees do I need to go? 220. So that will be a past like 180, right? Okay, so here's 360. Chris, look over here. So we start here, that's 360, and then we need another 220. So that will be like 40 degrees past there. Now, reference angle. Terminal side, x-axis. And again, reference angle is acute, so you can find it this way. Ooh. Let's say 580 minus 360.
So the original angle would be...
The original one was 580. 580 degrees.
So why didn't you subtract it from 360?
Why did I?
Yeah. We're gonna get 220.
220, and then we're also gonna subtract 180.
Oh, because you did a full circle and then it's... Oh.
Okay. Yeah. So if we do that, do we get it? Yes, we do, right? 400, yes, 40 degrees. And I was honest with you. I told you I have a hard time doing the numbers. I mean, I'm really good if I draw it. Okay, the next one is 8 pi over 3. Is that going to be, if we were to convert this to a mixed fraction, it will be something like 6 pi over 3, right? And that will be the pi, yes. That's all right. So what you guys are telling me is 2 pi, right? Plus 2 pi over 3. Now in this case, so Chris, when we talk about radians, it's always, the whole circle is going to be 2 pi. And then like half the circle is pi, okay? So then for this one, 8 pi over 3, so that means we start here, standard position, and then we go one complete turn, that's 2 pi, that's what we have here. And then we still need to go another 2 pi over 3, so that will be here. Now the reference angle is there. Now for this one, I could figure it out doing this. We are here at pi, right? So we could say pi minus 2 pi over 3, and that would give us what? How many thirds are in a whole? 3, right? So this is like 3 pi over 3.
So pi over 3?
Minus 2 pi over 3, so pi over 3, yes, Lisa, very good. Pi over 3, that's the reference angle. Okay, very last one is negative. So that will be negative 13 pi over 6. Let's convert this one to a mix, like a mixed fraction. So that will be, how about negative 12 pi over 6, and then minus pi over 6. So this will be like negative 2 pi minus pi over 6. So this angle is negative. That means I need to go in the clockwise direction. So it will be a complete turn. Now when we do negative angles, remember you go this way. So that's one turn. And then how much do I need? Another pi over 6 is just negative. Now the reference angle is going to be formed by the terminal side and the x-axis. That's the reference angle. And so that one is actually going to be pi over 6. I I really don't know how we could find it numerically. What do you guys think? Theta prime, we could find it. Let's see. Let's think. Because I don't want to end up with a negative result. I guess we will say something like 13 pi over 6 minus 2 pi. That's what I would say. So that will be like 13 pi over 6 minus 12 pi over 6. And that gives us pi over 6. Like I tell you guys, I'm not really good at doing this numerically, to be honest. All right, now why do we need all these reference angles, you might be thinking? Okay, so we need them because we could find the value of any trigonometric function of any angle. Once you are very familiar with the unit circle, it becomes more meaningful. So before we do that, I'm going to go ahead and write down, let me add a page here. So I can write down what we need to know at this point. And you could just write it down and find some room on your handout. So things that we really need to know is how our signs go, if it's positive or negative, of course. And so remember that I told you I will always refer to them as sine, cosine,
Is this the one we did in the beginning?
and tangent. Say that again?
Is this the one we did in the beginning?
Maybe. Yeah, but it doesn't hurt if you write it again. Okay, so sine is related to the y-coordinate. So the y's are positive in which quadrants?
And 1 and
Okay, now the cosine is positive in which quadrants?
1 and 4.
Oh, I'm sorry. Let's finish sine. So sine is positive in quadrants 1 and 2, negative in quadrants 3 and 4. Cosine is positive, you say, Brisa, 1 and 4. Very good. It is negative here and here. And then finally, for tangent, since this is a division of one over the other, tangent is positive here and here, but negative in quadrants 2 and 4. Now, that's something you really need to know by now. Now, what I would like for you to do, and just find some room on your paper, we're going to make this quick table. Oh, also, very important that we know the following. If we have a unit circle, we should know the coordinates of these points that are intercepting the x and the y-axis, right? So if we say unit circle, that means the radius is equal to what?
1.
1. So the coordinates here for this point will be?
1, 0.
Oh, yes, 1, 0. Okay, and then this point up here will be?
0, 1.
Okay, and the point here is negative?
1, 0.
And the one down here?
Negative 0, negative 1.
0, negative 1. Okay, and so we should also know the angles that correspond to that, right? So 0, 90, or pi over 2. This will be 180 for pi. Down here we have 270 degrees. 3 pi over 2. And finally, here, once we complete a rotation, we will have 2 pi and 360. So also, you guys should be very familiar that the x-coordinate refers to the cosine of an angle, correct? And the y-coordinate refers to the sine of an angle. So in this case, if I ask you what is the sine of 0 degrees or the sine of 2 pi, it will be 0. If I ask you what is the cosine of 2 pi, it will be 1. If I ask you what is the sine of 90 degrees, it will be 1. Okay? So now, what I want you guys to write here on this table, we're going to write down the other angles that are very common, and those are actually 30 degrees, or pi over 6. Here we have 60 degrees, or pi over 3. And here we will have, I'm sorry, actually have 45 here. Let's go in order. 45 degrees and pi over 3. And finally here we will have 60 degrees and pi over 3. The other one should be 4. Now, I've seen students confused sometimes. They match 30 degrees with pi over 6 because they wanted to have that 3 and the 3 on the denominator, but that's wrong, okay? So you always need to relate 30 degrees with pi over 6. And then you need to relate 60 degrees to pi over 3, okay? Now let me ask you something. What is bigger, 30 degrees or 60 degrees? 60 degrees, right? Okay. So pretend you are at a party and you buy a pizza. You're broke. You only have $5.
It's not even enough.
And 40 cents. And 41 cents. Okay, so but luckily there are only 3 of you there.
Still not enough.
Okay, or probably. So, or pretend you're at another party where there's 6 of you. Which party will you get a bigger slice of the pizza?
Oh, well, there's
Only 3, right? So pi over 3 is bigger than pi over 6, right? Remember that. Pi over 3 is bigger. That's why don't confuse yourself. 60 is related to pi over 3, okay? All right. Now remember I told you sine is like one of those that if you know that one you can pretty much get everything else. So the sine of 30 is 1/2, but a little trick that I read this on the book was to say square root of 1 over 2. The next one will be square root of 2 over 2, and then the last one square root of 3 over 2. And of course square root of 1 is 1/2, right? That's why we say 1/2. But now when we talk about cosine, we can go in reverse order. So we start here with the big angle 60, and that will be the square root of 1 over 2, square root of 2 over 2, and this is the square root of 3 over 2. Okay? Another thing, Chris, that we went over, that I know you will catch up on, right, this weekend? Okay? So that was the fact that the sine of 30 is the same as the cosine of 60.
So it's just like, does that apply for any angle, or is it only those?
If they're complementary, yes.
Okay,
So that's why the sine and the cosine of 45 are the same, because 45 and 45 are complementary. They add up to 90. So when we say cofunction is that. And it's the fact that like if you have a triangle like this, 90, 60, and 30, whatever is the sine of 30, let's call this C, A, and B. So the sine of 30 is defined as the opposite over the hypotenuse. But if I ask you what is the cosine of 60, that is adjacent, so this is the side adjacent to 60, which is also A. And then the hypotenuse. Okay, so that's another reason, but that will be in one of the videos. And then finally tangent. I know this is boring, guys, but like seriously, it doesn't hurt to say it over and over. Remember Dr. Carrillo? Repetition. Repetition. Okay, so tangent is sine over cosine, right? I'm just going to write them down quick. I hope I can. So this will be the square root of 3 over 3. This will be 1, right? Because you divide the same over the same. Tangent is sine divided by cosine. So if you divide this fraction over this fraction, you get 1, okay? And then this one here is going to be just the square root of 3. All right, this is why we need the reference angles. Because it is assumed that if you know the points and you know this table, you're good to go. You can find the sine, cosine, tangent of any angle. All right? So let's try to do this quick. I know I already took more than 30 minutes. Oh, is that it? No way. Oh, we're missing that one. It's the last one. It's the last one. We'll try to do it quick, okay? Sorry. I'll try and move fast. So let me just plot this angle quickly. So it's 120 is going to be before 180, right? And so the reference angle is going to be here. So that reference angle could be found by subtracting 120 from 180, correct? And that will be 60 degrees. Maybe my drawing is a little off. But now remember, is tangent going to be positive or negative in quadrant 2?
Negative.
Negative. So this is the same as the negative tangent of 60. What is the tangent of 60? You should have it on your notes. I just wrote that little table.
Square root of 3.
So this will be the negative square root of 3. And that's it. All right, let's go to example 7. Okay, so we have sine of 135, and I think we already know what the, what are they called? Reference angles are, right? For 135. So in this case, theta prime was 180 minus 135. So that gives me 45 degrees. So now the sine of 135 is somewhere here. Is the sign going to be positive or negative there?
Oh, is it positive?
Positive. This is the y's, right?
Oh, yeah.
Related to the y's. The reference angle is right here. It's 45. Do we know what the sine? So the sine of 135 is the same as the sine of 45 degrees. And of course, we know what that one is, right? Yes. So one thing that is actually very important is that you guys you find the appropriate sign. So if you could please circle, highlight, or whatever you want right there. Just like I asked you here, is the tangent going to be positive or negative in quadrant 2? Okay, so let's move on to the next problem. So we have 4 pi over 3, right? So just quickly, I'm going to plot it. We're going to go over pi, right? Because pi is equivalent to 3 pi over 3. So my reference angle, which is right here, is going to be pi over 3. Very good. We went pi over 3 past pi. Kind of like when you tell time, Chris. Like 15 after 2, or, you know. Okay, so do we know the sine of pi over, I'm sorry, not the sine, but the cosine? 1/2. 1/2. So the cosine of pi over 3 is 1/2. Now, let's just check. Is the cosine in quadrant, because we still need to consider this angle, right? The terminal side is in which quadrant? 3. So is the cosine positive or negative?
Negative.
Negative. So then we'll say the cosine of 4 pi over 3 is negative 1/2. So it will be the same as pi over 3, but negative instead. Okay, next we have your cotangent. And we have a negative angle. That negative angle is negative pi over 3, so right here. Well, maybe a little more. That will be negative pi over 6. That's theta. Our theta prime, the reference angle, is simply positive pi over 3. So now the cotangent of pi over 3. Now you guys have on your table the tangent of pi over 3, right? Yes, it is going to be negative. Well, not of pi over 3, but when we say the cotangent of negative pi over 3, yes. It will be negative because that will be negative, so that's good that we get that. Now going back to your table, you guys know the tangent of pi over 3, right? What is the tangent of pi over 3? Square root of 3, right? That means it's that. So the cotangent is the reciprocal of it, so it will be 1 over the square root of 3. And then after we rationalize, we will get the square root of 3 over 3. That is the cotangent of pi over 3, the square root of 3 over 3. However, the cotangent of our angle will be negative. So negative square root of 3 over 3. Okay, and I just want to stop here. Those last two, I will leave those for you guys. I think you can handle them. Just so you know, the reference angle for this one is going to be, it's going to make 4 complete turns in the negative direction, and then it's going to go a little pi over 4 after. Okay, and for the one here, the reference angle is going to be, we will have 12 pi over 3, which is equivalent to 4 pi, right? Isn't it? So it's going to go 2 complete turns and then an extra pi over 3. So the reference angle for that one will be pi over 3. So I'm going to stop the video here. And then if you guys need to use the restroom, go ahead and use it quickly. The very last slide is just like a summary of all the stuff that we've been talking about. Okay? So go quickly and then come back and then we'll get started with the exercise.